Major advancements in bomber technology during the Second World War was the key to the initial exploration of international air travel. Many of the early examples of passenger aircraft offered only one class of fare, first class, and it was spacious. Over the years, airlines and manufacturers sought to make flight available to the masses, and seat sizing and space per passenger were continually squeezed to make international travel affordable. In the short history of overseas air travel, there are perhaps only 4 or 5 planes that were built that could be considered quantum leaps in the expansion of intercontinental flight. Today, a European company is building an aircraft that will, like yesteryear, offer the passenger space and comfort. The new aircraft can provide this while being substantially cheaper to operate than its competition. The new era in civil aviation is about to be born, but to find the earliest form of mass air travel, we have to look far back in time. The first real passenger-carrying aircraft was the airship, which took to the skies around 1900. Von Zeppelin is regarded as the father of the airship, and by the outbreak of World War I, his Zeppelins could achieve 84.5 miles per hour. Von Zeppelin's success inspired many countries to develop airship technology. The United States Navy also saw military merit in the airship and built the Shenandoah, Akron, and the Macon. Unfortunately, newspaper images depicting wrecks and fireballs, such as these of the Shenandoah, imprinted strong feelings of skepticism in the public's mind. The truth is that many airships were built and flown successfully. Perhaps the public's natural skepticism of flight in general during the airship's reign is responsible for today's misunderstanding of these lighter-than-air giants. Interestingly, the airships of yesteryear are still the largest craft ever flown. The Hindenburg was over 820 foot long, and that's more than twice the length of anything we fly today. Passenger aircraft didn't become realistic until after World War II. Great strides had been made in all aspects of aviation during the war years, and the aircraft manufacturers began to convert newfound military technologies to civilian application. Boeing saw a rising public interest in intercontinental flights that were comfortable, safe, and fast. So they made some alterations to the B-29 bomber, and the first real luxury passenger plane was built. It was the Stratocruiser. The plane was a double-decker design that could accommodate 81 passengers in the upper cabin and 14 in the lower-level bar and lounge, which was accessible by a spiral staircase. Passengers experienced glamour on the Stratocruiser. 28 sleeping berths were located in the forward cabin for long flights. And on the Chicago-Minneapolis route, they were even treated to an in-flight fashion show. Unfortunately, the Stratocruiser quickly lost popularity. The Pratt & Whitney engines were costly and temperamental and often caused delays, and the airline companies were looking to air travel more affordable for a larger market. Sleeker planes with a focus on increasing passenger numbers per flight began to dominate the skies. apart from its size, the Stratocruiser is mostly remembered for its first-class luxury. Although many fantastic passenger planes followed, it will not be until 2005 that a commercial passenger plane of comparable luxury will be in operation plying international routes. It will surprise many people that the first passenger planes were mostly seaplanes. In the early days of air travel, few runways were available. However, many inland waterways, bays and inlets offered ready-made airports, and these were exploited until the end of World War II. The Martin Mars is one example. It has a wingspan of 200 feet and a height of 48 feet. The Mars was the largest aircraft in operation from 1942 until the first Boeing 747 flew. Another example of a large seaplane is the HK-1, or better known as the Hercules flying boat. It was, at the time, the largest aeroplane ever built. The Hercules' first and only flight occurred on the 2nd of November 1947. Howard Hughes fired up the 8 radial engines for taxi tests and thrilled thousands of onlookers with an unannounced flight. The Hercules lifted 33 feet and flew 1 mile in less than a minute at a top speed of 80 miles per hour before making a perfect landing. Howard Hughes designed this craft, and his small but dedicated team constructed the plane. As ordered by Hughes, it was constantly maintained and kept in flight-ready condition until he died in 1976. Howard Hughes also played a major role in bringing to life one of the world's most outstanding passenger aircraft, the Constellation. At the time, Hughes was heading TWA, and he approached Lockheed with a very specific outline of what he wanted in a new commercial airliner. His requirements were a plane that could fly the New York-Los Angeles route within 8 to 9 hours non-stop. The craft was to exceed a payload of 6,000 pounds. It was to have 4 engines and be fitted out luxuriously. Up until the time of Howard Hughes's new challenge, the manufacturers were just treading water, and no quantum leaps were foreseeable. The Constellation's production was delayed due to the war. However, it made its debut flight in 1944, with Hughes himself as the pilot. He flew the Constellation from Burbank to New York in a record 6 hours and 57 minutes. He covered a distance of 2,300 miles with an average speed of 330 miles per hour. It's interesting to note that the Constellation was faster than most fighter planes of the day. It wasn't until 1946 that the first TWA Constellation began commercial service. The first services were transatlantic, and a month later the domestic routes were opened. Most of TWA's competitors were still operating the reliable but dated DC-4 workhorse. The Constellation was much faster, more comfortable and stunning to look at. The Connie was the queen of the skies. The Constellation was so far ahead of its competition that it forced most of the major airline companies to place new orders with Lockheed. A stretch version of the Constellation was built, and it was about 18 feet longer than the original. This model became known as the Super Constellation. The Constellation's 12-year production run was doomed by the development of the jet engine, which allowed airlines to pursue the goal of cost-effective travel for the wider community. Jets were faster and more efficient. The jet age of passenger planes had dawned, and a new era of aviation was born. The name Rolls-Royce is synonymous with turbine fan engines. as it's one of the earliest pioneers of jet engine production. This engine is the latest development of the Rolls-Royce Trent series. It's the Trent 900. This is the engine that will power Airbus to the forefront of passenger aviation. The engine recently completed a series of high thrust tests, and the first development engine reached 88,000 pounds of thrust, which exceeded the performance for entry into service. The first development engine is already returning to the testbed after being stripped and rebuilt to incorporate modifications. The second and third of a total of 7 engines to be used throughout development are now being assembled. The Trent 900 is the only engine offered for Airbus's A380 and will be certified in October 2004. The A380 will be the world's largest airliner, easily surpassing Boeing's 747. The construction of the Airbus A380 is equal in commitment, innovation and technology advancement to any civil aircraft program preceding it. Airbus first began studies on a very large 500-seat airliner in the early 1990s. The project's goal is to create a competitor and successor to the Boeing 747 and to end Boeing's dominance of the very large airliner market and round out Airbus's product lineup. The Stratocruiser, Super Constellation and 747 were all huge steps forward for civil aviation. The A380 will be a quantum leap in advancement, and its sheer size already places it in aviation's Hall of Fame. But it's not just its size that the A380 will be admired for. When the A380 takes to the air, it will be the first time since the Stratocruiser's last flight that a truly glamorous and luxurious passenger plane soared the sky. The A380 has about a third more seating and far more available floor space than its closest competitor, the Boeing 747. A380 has an unparalleled level of comfort, with wider seats and aisles, open spaces for passengers to stretch their legs, and access to lower deck amenities, which may contain sleeper cabins, crew rest areas, business centres, gymnasiums, duty-free shops, or even a creche. The A380 achieves this with a 15 to 20% lower seat operating cost than a 747. In fact, the A380 consumes less than 0.8 of a gallon of fuel per passenger over 62 miles. It's a consumption comparable with the best of small, modern turbo diesel cars. It took a huge gamble for Airbus to reverse the trend of less space and tighter seating, and they achieved this with innovation. The A380 will be the first Airbus aircraft ever to boast a carbon fibre central wing box, representing a weight saving of up to 1.5 tonnes compared to most advanced aluminium alloys. An estimated 40% of the aircraft's structure and components will thus be manufactured from the latest generation of carbon composites and advanced metallic materials, which, besides being lighter than traditional materials, offer significant advantages in terms of operational reliability, maintainability, and ease of repair. The weight savings resulting from innovative production allow the A380 to weigh in at around 530,000 pounds, which is up to 33,000 pounds lighter than a similar-sized aircraft using 747 technology, and the entry into commercial service with Singapore Airlines is scheduled for March 2006. Airbus was established in 1970 as a European consortium to oppose Boeing's dominance of the long-range civil aviation market. It was clear that no single company could compete with the US giant. When Airbus began, its main competitor held about 90% of the market share. Today, that gap has closed extensively, and with new models such as the 330, 340 and 340-600, the gap is closing to a 50-50 share. In fact, the Airbus's A330, A340 family has established market leadership in the 240 and 380 seat category. The twin-engine A330 combines some of the lowest operating costs of any aircraft ever designed, with maximum flexibility for a wide range of route structures. The A330-300, which first entered service in early 1994, typically seats 335 passengers in 2 classes, or 295 passengers in 3 classes, and can fly up to 6,500 miles. Airbus's design team were faced with a problem when concepting the A330. Airbus management really wanted 2 planes, one for shorter routes and another for very long-range work. They wanted to break into the 747's domain. The design team and engineers did something revolutionary. They created a plane that could be fitted with 2 or 4 engines with very little alteration. Two-engine aircraft are more economical on short or medium-range routes. However, international aviation law requires 4-engine planes for very long-range routes. The remarkable operating efficiency of the A330, A340 family is enhanced by voluminous underfloor holes, which generates cargo revenue. The A330 and A340 can carry 60 to 100% more freight than competing aircraft. The unmatched economics of these planes mean they can operate profitable cargo flights without a single passenger on board. The A340-600 is one of the latest additions to the A330, A340 family. It's the longest and quietest commercial jetliner to take to the skies. Another of Airbus's innovations, which was developed in 1991, is the family concept, which includes the introduction of fly-by-wire on commercial jetliners and CCQ, or cross-crew qualification. In essence, this allows a single-type qualification across a range of aircraft. This extends from the A318 to the A340. An A318 pilot can simply receive a few days' training and be certified to fly an A340-600. Rolls-Royce was chosen to provide the power plants. The Trent 500 made its first testbed run ahead of schedule at Rolls-Royce in Derby during the May of 1999, and it achieved 60,000 pounds of thrust. Airworthy clearances were received in December the following year. The operational ratings of 53,000 and 56,000 pound thrust are well within the engine's limit and even allows margin for future expansion. The first production engine was delivered to Airbus in March 2000 and made its maiden flight 3 months later. Development engines completed more than 4,500 hours of running, which included operating in simulated extreme weather conditions. During takeoff, the engine sucks in over a ton of air per second and squeezes it up to 40 times atmospheric pressure. The blades of the Trent 500's 97.4-inch diameter fan are made from titanium and have a hollow centre, making them light yet extremely strong. At the engine's core, the fuel burns at approximately 3,600 degrees Fahrenheit. Metals in this part of the engine start to melt at 2372 degrees Fahrenheit, so sophisticated cooling techniques are used. The Trent 500 can deliver an equal amount of power as about 1,000 family sedans. Aviation milestones have been born by vision. This is Jack Northrop's Flying Wing, a truly remarkable design for its day. The design did away with conventional features of even modern planes. It had no fuselage or tail assembly. The plane was ordered by the US military. However, Northrop's dream was to see thousands of his planes in the air, providing economical and luxury air travel to the masses. This is a mock-up of a prototype of the commercial variation of his Flying Wing. The leading edges of the wing were to be of plexiglass to optimize natural light and viewing pleasure. It was to carry 80 passengers in a 53-foot long area. The ability for passengers to move around and to mingle at the bar was also an important aspect of the Flying Wing experience. Northrop's dream was not realized, but his ideal to produce a plane that can carry passengers in a spacious and comfortable environment within an economically viable model has until recently dogged every aircraft manufacturer. Current tests and data indicate that Airbus may very well have achieved the holy grail of commercial aviation with the A380. That concludes this episode of Flying Through Time. Join us again when we further explore our fascinating and remarkable history of flight.